So we're looking at radicals or surds in this video, and for that we need to know our square numbers, because these are going to be the most important thing to simplifying these. So our square numbers are 1, 4, 9, 16, so this is 1 squared, 2 squared, 3 squared, and it's handy to know all the way up to 15 squared, which is 225. So what actually is a radical? So let's write out a radical number. A radical number is something that's expressed as a square root, so something like the square root of 2 or the square root of 7. I mean, there's lots I could choose. One that's not a radical is something like the square root of 4, because the square root of 4 can be expressed as plus and minus 2. Another example of something that's not a square root is any of these square numbers. So 25 is 5 squared, so that could be plus and minus 5. Right, let's have a look at how we can simplify some of these. So let's take something like the square root of 12. Now 12 is not a square number, but there is a square number that divides into 12, and that's 4. So I can rewrite that as 4 times 3. Now 4 times 3 inside that square, I can do this. I can split that square root sign up like this. And I can then say the square root of 4 is 2, and the root 3, the radical root 3 part, cannot be simplified. So that will be our answer. Let's do another one. Let's do the square root of 50. So is there a square number that divides into 50? Well, I think that square number that divides into 50 is 25, so it's 25 times 2. So then we can say that this is 25 times root 2. I know that 25 is 5, and just for convention I'm taking all the positive numbers here. So we're beginning to see how we can simplify some of these radicals. Let's have a look at another one. Let's have a look at 500. Now, you may think, well, 25 goes into 500, and that's fine. So 25 goes into 500. How many times? You can double check this. I'm just going to double check on my calculator. It goes in 20 times. We already know that 25 is a square number, so that becomes 5 and root 20. But the root 20 could also be simplified. I could write that as my 5 times 4. Now I don't know the square root of 5, but I do know the square root of 4, which is 2. So that 4 comes out to give me 2 and leaves me with 5. And that gives me 10 root 5. Now that's fine, but could we have done that a little bit quicker? Well, we could have done by looking for the highest square number that comes out of 500 or factors into 500. So that's 100 times 5. 100 is a square number. The square root of 100 is 10, and it leaves me with the root 5, which I can't simplify. So here, instead of doing all of this work here, starting off with just the 25, it's a lot easier to go for the highest square number that comes out, and that will save us a lot of work. So let's just keep going with this. Let's pick some other numbers to be simplified. Let's do something like, let's just extend these rules to think about something like 180 take away root 72. Now we are not allowed, I'm going to write this, but you are not allowed to say that that's the square root of 108. That does not work. Not true. But what I can do is I can think about simplifying 180, and 36, which is a square number, divides into 180. So I can do this as 36 times 5. And then I can take away, well, 36 also goes into 72, so I can do 36 times 2. So here we can have this rewritten as 6 root 5 minus 6 root 2. Now we've got a root 5 and a root 2. We can't do anything with that. However, we could maybe simplify something like this a bit more. The square root of 20 add the square root of 180. Now again, we're not allowed to say that this is the square root of 200. Instead, we will simplify the root 20, which I think we've already done something similar to this. That's 2 root 5s. And the 180, we've actually done it up here, this one here. So that's 6 root 5s. Now we are allowed to add these 2 root 5s together, so that gives me 8 root 5s.